For a second example, I would like to take the piecewise function f of x equals 1 plus 3bx plus 2x squared when x is less than or equal to 1, and mx plus b when x is greater than 1, and make it differentiable everywhere. The only place where I could have an issue with it not being differentiable, because those pieces are really just polynomials, is at x equals 1. So that's what I need to focus on. First, I'm going to go and I'm just going to calculate my derivative. So I'm going to say f prime of x equals, well, the derivative of 1 is 0. The derivative of 3b times x, that's just a constant times x, is just the constant 3b. And the derivative of 2x squared is 4x. So 3b plus 4x when x is less than 1. The derivative of mx is just m, and the derivative of b is 0, so just the constant m when x is greater than 1. Now I need to make sure f of x is continuous at x equals 1. So that's the first thing I'm going to set up. I'm going to say f of x must be continuous at x equals 1. So that gives me the three-part equation, the limit as x approaches 1 from the left of the function equals f of 1 equals the limit as x approaches 1 from the right of the function. From the left of 1 and right at 1, we're defined by the top piece, so 1 plus 3b times 1 plus 2 times 1 squared equals m times 1 plus b. So I'm going to get 1 plus 3b plus 2 equals m plus b. I'm going to combine like terms, move the b to the left, and that will give me 3 plus 2b equals m. And that's my first equation. Then I need to make f prime of x continuous at x equals 1. So I'm going to say the limit as x approaches 1 from the left of f prime of x equals the limit as x approaches 1 from the right of f prime of x. Plugging in 1 to the left side of the derivative, I get 3b plus 4 times 1. Plugging 1 into the right side, well, I just still have that constant m. So I'm going to get 3b plus 4 equals m. And by now, I have two equations, and I'm going to go and solve the system. Well, since they both equal m, I can just set them equal to each other. So I'm going to say 3 plus 2b equals 3b plus 4. I'm going to subtract 2b from both sides. 3 equals b plus 4. Subtract 4 from both sides. b should equal negative 1. Plug that in. I'm going to say m equals 3 plus 2 times negative 1. m is 3 minus 2. m equals 1. When m equals 1 and b equals negative 1, that piecewise function is continuous.